This is the Amp Hour Podcast, recorded on January 20th, 2014. Episode 181, with guest Dave Vandenbout, Xceptional, XESS, Xenagogue.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble from Contextual Electronics.
And I'm Dave Vandenbout from XESS Corporation, and that sound you hear is Chris and Dave scraping guests off the bottom of the barrel.
At the bottom of the lab floor.
Yeah, really.
No.
No.
Dave's just so busy. We could not get a hold of him. He's making too many FPGA boards, and yeah.
Thanks for joining us, Dave.
Thank you very much for having me on, guys.
And you're a listener too.
Yes, I've been listening since show 16, sitting out in the parking lot of Lufkin Middle School, waiting to pick people up and listening to you guys on the radio. Well, actually,
Awesome.
on the thing that plays to the radio.
Right. Yeah. Radio is pretty tenuous proposition these days. You never really know what it actually is.
Yeah, exactly.
So we were interested to learn. So you were one of the sponsors for the 555 contest, right?
Yeah, that's how I actually first got on Twitter, and was when I saw an announcement in EDN or EE Times about the 555 contest, and I said, I got to get in contact with these guys and donate some boards to you. And the only way I could find any link I could find was on Twitter. So then that's when I got on Twitter. And
beginning of the end.
Yeah, proud to say that over 3 years I've amassed a massive following of 314 followers.
That's right.
Yeah. With a bullet.
Good times.
There you go.
Good times.
And ironically providing probably some of the most complex silicon available today as a prize for some of the oldest silicon known to man.
Time to upgrade, son.
Exactly. You know, some of the people that I sent prizes out to, you know, they said, well, I'm not even really sure what this thing does, you know.
That's good, though. You know, you got to start somewhere.
Well, yeah.
We were surprised to learn how you actually pronounce the company name, because I've been saying this wrong from the beginning since you did sponsor the contest. It's actually XS. I always thought it was XESS, or I don't know.
I mean, a lot of people have done that. When we first started the company back in the late 80s, around 1990, it was actually called X Engineering Software Systems, and that's still the official name of the company. But it was always easier to say XS. And then whenever you tell anybody that on the phone, they say it's Access, and they say ACCESS, which used to be an old Microsoft database system. And
right.
And then then we named, having a board named Zula now, which is XULA, and it's pronounced Zula, which gets them even more confused. And well, I solved all those problems. I stopped answering the phone.
There you go. I would start doing it like no XS, like the band in excess, but no Y.
Yeah. Not many people remember In Excess though.
Oh, come on, man! Were they the ones Come Sail Away? Wasn't that them? Was that them or no? Someone else.
Yeah, that was. Wasn't that Rush? Come Sail Away with me.
No, I don't know if that's.
You're the music.
It definitely was not In Excess.
No? Oh, jeez. Who was it? Now I gotta look it up. I'm singing it in my head like Cartman sang it, basically.
They are an Australian band, by the way.
Styx.
Oh, yeah. Men at Work,
Australian,
too.
thank you very much.
In Excess was?
Yep.
Yeah.
Yep.
Okay. Yeah, they were like a big romance band or something, or like a hair band or something like that, weren't they?
No, they
In
were.
Excess?
No.
Man, I don't know anything about
music.
music.
I don't think they were a hair band. I know they weren't romantic.
No?
No, Come Sail Away. I'm sure that I'm pretty sure that was
Rush. That was Styx. That was Styx.
Oh yeah, Styx.
Goodness gracious, people.
That's right.
Can we get back to the 1990s here?
Oh, I guess so, yeah.
And you've been running the company since the 90s. Tell us about it. How did you get into it? Where did you work before? Did it start as a midnight engineering company in the garage? Is it still a midnight engineering company in the garage?
Well, it's one guy, and that's me. But I started off in '79 with Bell Laboratories and worked there until 1983, and went back to school to get a PhD. Worked after the PhD. I was a university professor for about six or 7 years, and while I was there, one of my actually the professor that had advised me as a PhD student had hurt his back and was lying in bed and didn't have anything else to do, so he wrote a spreadsheet that runs on scientific workstations. At that time, they were like microvacs, things like that back then.
Right.
And back then, when you wanted to use a spreadsheet, you used it on a PC. So you did all your accounting and everything on the PC for your funding and everything, and then you drag it all over onto your workstation, and you do all of your documentation and everything on the workstation. So he said it'd be a lot easier if we just had a spreadsheet that worked on a workstation. So he did that, and it looked like there was some interest commercially in providing that spreadsheet on workstations to all the other engineers and scientists out there that use that. And so I got involved with him, and another guy got involved with him. We had a kind of a company on the side while we were university professors working on that spreadsheet. And that was back when you could sell a spreadsheet on a workstation for $995. And
holy crap!
Oh yeah, man! It was a great market to be in if you could reach those people, but you didn't have the internet back then, so you had to advertise through magazines, and you had to have retail package and stuff, retail package software boxes and everything. And so we hired we went into a cooperative venture with a marketing company that had been marketing software for quite a while. And that didn't turn out so well. And eventually, years later, probably around 96 or 97, the software, the spreadsheet software was kind of just booted out of the company. And I took over most of the company to do what I'm doing now. But what I learned when we were doing that, when we were trying to develop the software as professors and get it sold while maintaining our day jobs, is that didn't work out very well. I said one time, I said, you can stand on the dock, or you can stand in the boat. But if you put a foot in the boat and a foot on the dock, you're going to end up with your ass in the water, and that's where we are right now. So,
I like that. Yeah. And your groin's going to hurt the next day too.
Yeah. So they stayed with the university, which was a wise thing for them to do. But I just was not really
you fool?
that.
You went off and
yeah. I really. Published a lot of papers and all that stuff, but at the end of it, it turned out to be that you're spending all of your time looking for money and then looking for students to do the research while you write another grant proposal to get some more money to go find some students to do some more research, and you're never really doing anything except kind of like managing this kind of a research team, but not doing any of it. And I've always heard it said that what professors really want is they want to be a grad student, but they want to be paid like a professor, because
you're right.
The grad students have all the fun. So at the end of '93, I left, and I just used the XESS company that we had going there as kind of a framework to do things that I wanted outside of the university setting. So I just kind of went off to be a consultant. And I'd love to tell you that I planned everything out, and I had all my ducks lined up when I did that, but pretty much I never planned anything in my life, and I just kind of left the university and said,
neither has pretty much any other engineer.
I was going to say, you're good company here.
So I just kind of went out there and I said, well, what am I going to do now? So the first thing I did in like '94 was I actually wrote a little book that I self-published called FPGA Workout, which took some lab materials that I used in the university and kind of packaged them up into a book that was about 200 pages long, and I had 2,000 copies of that printed up for like, I guess it was $4 or $5 a piece, and I had 40 or 50 boxes of books in my house, and I was selling those I mailed 300 of them, one to every electrical engineering department in the country. And back then, looking all those up was kind of hard. Finding out where all of them. And I was surprised that there were actually 300 electrical engineering departments in the United States. But I mailed off 300 of those guys, and I sold over the course of a few years. I sold 1,500 of them, and then I had that last 200 kind of like hanging around in the house. And I finally got sick of looking at them. I went out to the landfill and I had a bulldozer run over them.
Oh, no.
I mean, the thing is, it was based on an Intel FPGA. Did you guys know that Intel used to make FPGAs?
I did not know, and that's weird because it's come full circle. They're doing that again now, and they're
they're talking about it, aren't they?
They're making
no,
them.
they're doing
fabbing.
They're making them for other companies.
They're fabbing, but they're not doing that.
Right. But they had a chip back then called the FX780, and it was more of a CPLD actually. But the thing that distinguished it was that it had actually little 256 by 8 SRAM blocks in it, along with the logic.
Ooh,
and you could actually make a little microcontroller out of that chip and store the programs inside, which is something you couldn't do in any of the other chips. And so I had the book that I wrote, and it actually goes all the way through doing the logic design, and then it shows how to build a microcontroller that would work in the FPGA. And
which is interesting because that's how lots of them are doing embedded micros now as well, if not hard coded processors.
And the thing is, after I wrote the book and I actually developed a little board that used that FPGA on it, then Intel decided to get out of the FPGA business, and but luckily they sold
Thanks
it.
for that, yeah.
They sold it to Altera, and Altera rebranded the chip, so I could still keep selling that for a while. But then pretty much the market for that book went away, so there's a reason to finally drag them out in the landfill and let the bulldozers have them.
Go over them,
yeah.
So what was the market like in? I mean, '94. I mean, I know FPGAs and CPLDs were around since the '80s, right?
Yes, it's about '85.
Okay, so '94 was it mostly like military, like research kind of applications? Were there any commercial people doing that?
Lots of universities, lots of small engineering firms that wanted to get involved, because back then a lot of the FPGA tools were very expensive for people, and so I was offering a very low cost board, and the software that Intel and Altera eventually were offering was free, so you could get it and you could actually develop with the FPGA at that time, and do it all for a couple $100. It's interesting to talk about military and things like that. I had one guy call me up, and the product I was selling was called like a student EPX31. It was a combination of that FPGA and an 8031 microcontroller on the same board. And I was selling it mainly to students and universities and things like that. And he called up, and he was very interested in the board and said, "Yeah, we got to get some of these." He said, "The only problem is this organization will not buy anything that has student in the title." Because that's demeaning to us. And I said, well, kind of like if you pull the stick out of your ass, you could probably buy one, but that is an attitude you keep running into with people. They're so worried about being taken seriously that everything matters to them. It's got to have the right name, it's got to have the right look. But that was the market back then, and since then, it's really broadened out quite a bit.
Thank goodness.
but there's still a lot of fear in people when you say FPGAs that they go, I'm not sure I want to get involved in that. And really, when you look at the microcontrollers that people are using nowadays that have 5,000 page data sheets,
Yeah.
How does an FPGA even seem scary to you if you're using chips like that? Because,
why do you think people are still scared of it then? I mean, what do you see as your, I'm guessing you support a lot of the boards you do, so you probably get a lot of that, right?
Yeah, I think that the people that are scared of it is just that it's using different languages like VHDL and Verilog. It's not C, it's not C++, it's not Python, it's not this or that or the other. And with FPGAs, if you're not real careful with them, they try to do everything at once. I mean, you see people try to program FPGAs, and they'll get their Verilog or the VHDL, and they'll do it sequentially, and they'll think that that's how it should go. And then when you turn it on, it all there's no timing or anything. It just goes boom, and everything tries to happen at once.
That's the difference, because it's not a pre-programmed architecture, debugged, ready to run your sequential program.
Right.
In fact, it doesn't run a sequential program unless you actually design a processor into it. And that's the huge difference, because it's not just another programming language. It's a whole different way of looking at programmable devices.
Right. It's all parallel versus sequential. And if you're in a processor world, what you're mainly doing is sequential, and what you're worried about in a lot of cases is latency. Can I get to everything in time that's happening in parallel out in the world and handle it with my sequential process? What you end up doing is a lot of interrupt processing and worried about your latency. When you get out into the FPGA, it's all completely reversed. You're saying, it's easy to handle all these parallel processes, and I'm not worried about latency anymore. But now, how do I do the sequential stuff? And when you want to do sequential stuff, you have to do a finite state machine or something.
Exactly.
And when you do FSMs, as a professor in university, I found out students do not like FSMs very well, and they have a real hard time understanding those and writing them out. So, but that's what you got to use.
And that's the thing I found, because I've worked at a FPGA company, a company that thought they were an FPGA company that shall remain nameless.
We're really hiding your motive there, Dave.
Is that Pull Up Stakes Corporation?
Let's shoot ourselves in the foot, corporation. What was I going to say? The thing is, like, people grow up learning sequential programming. It's almost second nature to them, right? So when they want to get a job done, I use a micro. And, FPGAs are just put into the too hard basket unless you absolutely need to.
Right.
That's what I've found.
Right.
Like, unless you have that niche application that goes, look, this processor isn't going to do it.
Right.
I need to do some other
anything.
or
streaming.
Or handling 20 channels of ADC at once or something like that, all all in parallel, and processing it and doing FFTs all in parallel and all that sort of jazz.
Right. You pull the FPGA out when you need it, and that kind of
it's the tool of last resort.
Right, right, and that kind of goes hand in hand with what you were saying before. I think you said it, Dave. Is that the way to learn about FPGAs is to first have an application for it. If you have an application for it, then you can learn it, because then you can see how it fits into that application. If you just go at it, I'm going to learn about FPGAs. I'm going to do a little thing here, a little thing there.
I'm going to blink a LED and do a, it almost seems pointless. You go, I can do this with one line of code in my micro.
Yeah,
exactly.
And I do see, people do call up the company and they say, well, I want to use an FPGA for this, and I'll talk with them for a while about it, and I say, it's a low bandwidth thing that you're doing there. It's human interactions. It's really just going to be so much easier for you to do some things with a micro. If you've got something where you need where you have parallel processes and a lot of fast latency that you have to worry about, then you can start looking at an FPGA. But I try to give them. I don't always make a sale, but I try to get them at least pointed in the right direction.
Yeah. And that's one of the reasons why Altium... Oh, oops. named them, failed. Their complete vision failed because their vision was that the FPGAs would be the future and everyone would use them for everything, and that just hasn't turned out to be the case, and it's obvious, why. Well, there's other technical reasons as well, but it's always going to be a niche thing, I think. I just can't see them go in mainstream. Even the FPGA vendors, and this is the interesting part, we've talked about this before, even the FPGA vendors are realizing that it's not, the be-all, end-all tool we thought it would be, or the be-all, end-all chip. So they're now putting all these hard silicon on there, they're putting ARM processors on there, they're putting ADCs on there, they're putting all these hard peripherals on there to try and match the microcontrollers.
That was I think the entire motivation for the Zinc. When you look at the market materials for Zinc, one of the first things they say about Zinc is, hey, this thing starts without even having the FPGA programmed. You don't even have to program the FPGA to start working with the Zinc. So they're going to those software guys and saying, this is not as hard as you think, and you can start off with it right away. And
that's like the Altera system builder thing too, where they say, oh, you can design a whole system and we'll do all the back end stuff, and it's like, that's great until something breaks, and then you're screwed, or you need to do anything outside of what they already give you.
Yeah, then go and try to unravel all that spaghetti, trying to find out where that one thing is that's going wrong. And, that is one of the reasons why, there's a lot of... Well, let me go back a minute. I bought a Commodore 64 back in, 1982.
Wow, that is going back a bit.
But, the Commodore was a great system back then. Compared to the Apple and everything else, because it was so inexpensive, and you could get in there, you could understand all the things that were going on with it. And I don't program the Commodore anymore, but there are a lot of people who still do, and that's because it's a system that you can get into and understand what's going wrong and find it and fix it. And then, but with a lot of these systems that we have now that have such great capabilities, if anything goes wrong down in there somewhere, it's multiple days trying to figure out exactly why it is, because it's hidden under so many layers of abstraction, and it could happen in so many different places. You have to open up a box, look inside. There's another box in there. Open that box up. Oh, there's another box, and you look in there, and that's not the box. You close that one up. You go, you're saying, where is the problem?
Yeah. Is that always going to be the problem with FPGAs? I possibly think so, because by their very, ignoring the ones with the hard silicon on them, right? But just FPGA fabrics trying to do something, by their very nature, they are dumb. They're a sea of gates. They don't do anything. So you're always...
They're only as dumb as the guy programming them, Dave.
Exactly. So if you want to put a soft processor into that, well, it's code. It's not that hard silicon that's guaranteed to work. You've got all these massively complex software tools behind it to compile it all. But even if your soft core comes pre-compiled, there's so many... layers of that onion that can go wrong.
Well, really, there is that, but I think that problem still exists with hard-coded processors that you put on a board.
It can do.
You still put things around it.
But the chip is guaranteed to work, though. The chip that you buy, you know it's good. So, it must be a,
Yeah, but what if I took that soft core, that HDL, and made it into a hard chip, and then I gave it a hard chip? Then you would think that one is guaranteed to work. So you should be able to make the soft core be guaranteed to work if you run it at the same speed. The only real wild card in there is the development tools. If they shifted the development tools and they're mapping their gates differently, then if you got an error there, then you are screwed, glued, and tattooed.
Well, don't worry. Just upgrade to the next version, right? That's what they always tell you to do.
That's even worse.
Oh God!
Download our latest 3 GB patch.
Oh God!
So how do you deal with that work? I mean, because you work with this stuff I've worked with FPGAs in the past, but you're doing it every day. How do you even start to support all of these different boards that you build? And then, you probably get a lot of this ricocheting.
He doesn't
from these
have that
software.
many. That's how. Probably deliberately, right?
Well, the thing that I do is I try to make modules that abstract away some of the problems. Like I've got an SDRAM on the board, which is a big advantage in that it's cheap and it provides a lot of storage. Its disadvantage is that it's hard to use. So I've got a module you can pull into your Verilog or VHDL code, and it will make the SDRAM look like an SRAM. And that's been in develop. I've had that since 2001, and it's pretty well debugged and it works. And you can give that to your customers and say, all right, now you're not going to get all the flexibility you have with SDRAM if you do it all hard code by yourself, but it will save you a lot of troubles. It'll get you started faster. And when you hit a performance roadblock, you can change it around and you can start to do your own stuff after you're sure that your main system starts to work. Yeah. So I do, when I was young, I used to work as a bricklayer. Now I think of myself as a plumber. I make the pipes, I get them connected together, I hand them over, and then somebody else builds a house on top of that, knowing that they've got the water that's coming in. But
there's like a joke in here somewhere. I can't put
there's
it.
A bum crack joke.
Yeah, exactly. I'm not quick enough today. Need coffee.
There's a title
something.
for today's show. It's got to have bum crack in
it. Please, guys. I'm struggling with enough of a disadvantage in life without being the guy who's on the butt crack show. I mean, I know in 17 years or so, you guys are going to have your 1,000th amp hour show, and you're going to go back to them all, and you're going to say, "Man, let's pick out the one that's the most erudite, knowledgeable show of all." And and I'll guarantee you that show is not this show, but at least don't title it the Butt Crack Show. I don't know what I don't know what the alliteration would be on that.
Yeah, we'll work on it. We'll brainstorm after the
show. No butt crack.
Oh goodness.
Okay. So how do you decide then? Okay, so you've had a couple different product iterations now. How do you decide to jump to another logic family? And I mean, so you're mostly doing Xilinx stuff.
Yeah.
It seems like
people have asked for Altera stuff, and I say I don't really have any. There is no problem with Altera stuff, but to the average person, Altera, Xilinx is like Coke and Pepsi. I mean, there's nothing you're getting from one that, for the most part, you're not getting from the other. So I say, yeah, I could build an Altera board for you, but what I'm going to do then is I'm going to have two boards, two different families, no real difference between them. So I'm just going to be supporting twice as much stuff without getting twice as many different capabilities there. So the reason
to change would be when Altera approaches you and they say, "Well, we want another development board in the marketplace. And here's a nice discount on your chips."
I've actually designed development boards for both. So I've been involved with both, but right now on my own, it's just not worth. I can't deliver anything to my customer by having two families that I can't already deliver by having one family. So, but when I switch from one iteration to the next, it's mainly that the density has gotten up to the point where people are starting to expect it, and the prices have fallen to the point where it's viable for me to start putting them on there. And the availability is such that I'm not banging heads with a lot bigger customers that can buy up everything and parts on allocation, things like that. Back in around 2000, I did have a board called the XSV board, and it had an $800 FPGA on it. And the board,
good Lord.
The board sold
That's
for
cheap.
like.
What are you talking about?
The board sold for like $1,600. So I knew that I could not have the boards manufactured with the FPGA on them. So I had all the boards manufactured with no FPGA on them, and I would hand mount the FPGA, which was in a 240 pin PQFP. I'd hand mount one on there, and whenever I sold them, but it's an $800 profit on the board right there, so it makes it worthwhile to sit there and put the.
So
chips
you
on.
order one from DigiKey. So if you get an order, you place an order for one.
I would order trays. I would order trays of 30 from.
Oh, okay.
And one time I dumped a tray.
Oh my God!
I dumped a tray of $800 chips, and after I changed my underwear, I went back and started picking them up, and these were PQFPs, but they had a big They had a big heat slug in them. They weighed a ton. I mean, so when they fell, if they fell on their fins were like their pins were bashed in.
Thud.
Yeah. So luckily, only like 2 or 3 dropped to the floor, and they hit the carpet. And then what happens to a chip when you drop on carpet? Those little legs dig into the carpet, into the threads of the carpet.
Yeah.
So you gotta tease it out, and then I would get those chips back, and then with a little magnifier, I would pick at the pins until they all straightened out.
Oh man! And that was the day Dave got rid of his shag carpet.
Yeah.
Why shag? Why?
I've been a lot more careful with trays of parts since then, although I've never handled any that were as expensive as that. I mean, back then,
that's crazy.
That $800 chip was 800,000 gates. And now you're buying 1.5 mega gate chips, and they cost $30, I mean, there's no comparison anymore.
Right. Yeah.
Plus, they're BJs. You drop them, no big deal.
Yeah, as long as you don't step on them afterwards, you're fine. Man, that's crazy. So, it's interesting talking about these boards, too, because you abstract out one of the processes that always kind of tripped me up whenever, like, FPGA stuff came down. I mean, I guess you still have a little bit, but the pin association side of things, like when I guess it's less of a problem here, but I think about, you put down pins, you create a footprint in a schematic for an FPGA, and you give it a name, L12 or whatever it is, and then you hook it up to your memory, and then, it's the wrong pin. You think, oh, it's programmable, it's no problem, but then you're totally screwed because it's a memory-only pin.
That's where the 800-page data sheet comes in.
Exactly. So there's that, and then also making sure that your data file is right, even if you do hook them all right to where the I/O pin is hooked out to an I/O pin on your breakout board here, or the board I'm designing, the I/O pin, then you have to also go through and make sure each one's hooked up internally correctly, and it's just ugh.
Right.
I'm guessing you just give them a file, right?
Oh yeah.
Or you accidentally put one pin on the wrong bank, and you've just halved your performance. You halved your possible performance.
Right.
Like,
exactly.
Yeah.
Yeah.
And you don't find out until you spun your board.
Oh yeah.
Yeah.
What I do is I provide for a lot of the FPGA boards. I'll provide projects that go with those FPGA boards, and then I also have the smaller stick-it boards that have little peripheral chips on them that you can hook up to the FPGA, and each one of those comes with a design that shows how to use it and all the pin assignments that are there for it, and the manuals and everything have all that information in there, so they can trace back and say that this pin on the FPGA goes to this pin on the Zula board, and that Zula pin goes to this pin on that particular connector on that stick-it board. So they can trace through all that.
Right.
And then I have
the green grass grows all around.
Yeah. And I have some automated tools that help them map the peripheral from one port to another port if they decide to move it or things like that. But yeah, a lot of people have a lot of problems with assigning the pins and keeping them all straight. And then even when you assign them in the FPGA tool, sometimes those assignments don't take, and you've got to check your pin list to make sure. You got to go against the pin list and say, well, I said it was going to be on 812, and now it's on 813, so it shifted over a bit. Why did it do that?
Yeah.
It shouldn't do that. And you had to go through and pick that out. And that doesn't happen very often anymore that I've seen with my customers, but that used to be a problem, years ago.
Yeah, I do like those the CAD tools that do the the flexible pins where you could say, oh, this is a flexible I/O pin. You don't necessarily have to assign it to, as long as it's not a memory pin coming in or something like that, it's okay. You can just assign whatever there, and then the tool does the optimizing. That's always nice.
Well, I haven't used the FPGA tools for quite, seriously for quite some time now. How are they in terms of stability? Like, do you recommend people always keep up to date with the absolute latest version, or do you say, no, look, stick with this version, it's known solid performer, and it works with this board, no problems?
I think that most
is the software stability these days?
I don't have that much problem with the stability of the Xilinx tools when I use them, and I think most people just kind of follow along and grab the version of the tool whenever they get started. If you sell a customer a board,
right.
He's going to download 14.5 or whatever it is from Xilinx, and he's not going to go back.
Yep.
He's not going to go back to 13 or 12 or whatever, which I might have developed the designs in that go with that board, but he can still bring those forward, and they will still compile just fine on the 14 versus, when I did them on a 12 or 13. So it hasn't been that big of an issue with the designs that I'm doing. It's when you get to packing the FPGA full. It's when you get to driving the frequency up towards Fmax. That's when you start to run into those problems. And like I said, a lot of the customers I'm working with are just looking for a vanilla FPGA to get into their application, and they're not out there, doing a cell tower base station, which would be a different case.
Well, yeah. I've shot some videos of some FPGA development boards. I haven't released them yet because I'm going to do some more. It's going to be like 4 or 5 of them, and I found that this is one of the big name development boards, low cost, sub $100 development boards out there, and they sent it to me, and I installed. I just downloaded the latest tool, and as they recommended in their thing, and it just didn't work. And it was like, and then I went back to them and they said, oh, no, you've got to download this is an older board. You've got to download this older version of the tools, and it's like, so painful.
What was the thing that wouldn't work on that? I mean, it can't be pin assignments.
I can't recall off the top of my head, but it was just, it was just silly. It didn't support something or other, and I can't remember, but it was just a horrible experience. It really was. Imagine if you're a beginner. Geez, you'd be put off FPGAs for life.
Yeah, exactly.
Oh, well, right. I'll tell you, the guys that get put off FPGAs for life I can't imagine the number of times that I will get emails from people that say, I found this old XSV board, and I want to learn how to use it, learn FPGAs using this, but my computer doesn't have a parallel port on it anymore. And, you just want to say, that board is 13 years old. You do not want to touch that board. I mean, I know
this is not a 555 timer.
I know it's effectively free, but you would be much better off spending it, $70 or $100, whatever, to get a board that's current and avoid the headaches of, don't pull your hair out.
Is that because that's kind of different to the microcontroller feel, because most of the software will still support all these old boards and old chips and things like that. So, you can sort of use and drag out
a 13 year.
Yeah, exactly. The vendor tools will actually support them. They've always had the same, ICSP, programming interface. So as long as you can, your programmer can hook into that, you're sweet.
Yeah, but you're just writing code for that. You're not actually like putting programming gates. You're just, you're not optimizing.
Yeah, I know.
Gates.
Yeah, it's different. And there's one of the disadvantages. Yeah, I've got a ton of old FPGA boards here, and they're absolutely useless. There's just no point. I could give them away, but that'd be cruel because people just wouldn't be able to use them properly.
And the other thing is, at least for Xilinx, is in their Webpack tools, their free tools, they do start dropping off the older chips out of there because they don't want to support those anymore. So you can't compile for an XC4000 in Xilinx Webpack anymore. And I believe some of the Spartan 2s are dropping out of there if they haven't already. Which So you can't even go back and use those tools.
That's what happened on one of my boards. Yeah, just can't use them. It's a pain in the ass.
But I would imagine that you'd have a similar situation if you're updating your compiler technology, that you would still have a problem maybe with earlier chips if.
You could do. In my experience, not nearly as bad as FPGAs, though.
Yeah.
So that's,
I mean, you usually have a stack machine.
Programmed, 15-year-old micros.
Yeah, I mean, you have a machine that's got a stack, it's got an ALU, it's got a program counter. It's probably not going to be very too different from what you've already got today. So, yeah, I can see how that would still work.
Yeah. Smaller, lower power.
Yeah.
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 Do you notice the last time I was using FPGAs was when, do you remember the ISC that had like the big CD-ROMs with the F14 on the front of them? I think it was 12 or 11 maybe, but it's been a while. Whatever. Do you notice that some of the packing algorithms have changed over time?
Oh, you're talking about the place and route stuff?
Yeah.
Well, they're always trying to make it better.
It's not packing, Chris. It's place and route.
Well,
sorry.
I mean, there's there's the mapping phase and the packing phase, and then there's the place and route phase, and so on and so forth. You get the three phases in there, but they're changing the. And I don't work for Altair or Xilinx, obviously, but I've heard, or they have said that they're changing the routing algorithms or the mapping algorithms to take advantage of their Vertex 7 architecture. So they may not. They may not.
But what does that do to the other?
It may not be as good
support for the other devices.
It may not be as good for the earlier Spartan 6 or the Spartan 2s or whatever. But they've made their money on those, and that's not that can't be their real concern anymore. They've got to move on to Vertex 7 or Artix, Kintix, whatever they're calling.
Oh yeah, all that stuff.
So yeah, I mean,
silly names.
It's potentially possible you'll get your new compiler tools, your new place and route tools, and maybe they don't work as well with your older designs. And in that case, there's a good reason to have your virtual machine all loaded up with your old tools and ready to pull it out at any moment.
Right, yeah.
That's right. I mean, that's a very good tool or idea, rather.
That's what Jack Gansel talks about, with old processors, supporting old processors. Make sure you keep all of your old tools there and at least a virtual machine so you can start running
all
those.
that old DOS image, that image of that DOS hard drive with the parallel port.
And boy,
it.
when you go back to that, you really do cringe,
You start to appreciate the modern stuff, right?
Yeah. That's why I don't know why people go back and do a lot of that stuff with Commodore 64s and things like that, because I used that stuff, 30 years ago, and it was crap then, but but it was all we had, and it worked, it worked. It was fine. But I said it was crap, but
they do it for fun. You don't do it for any serious reason.
But I mean,
really.
they really get into it.
Around.
Yeah, they really get into it, and that's fine. I mean, they're all of humanity is a search function. We're all searching different things, and so they're just one search function that's looking over in that area, and I that's cool. But I really wouldn't want to spend my time doing that because I just cannot stand seeing that interface anymore. It's just it'll drive you nuts.
Anyway, do you share the pain that I've always had and many others have had with FPGAs? Is that to get high logic density, you have to get high pin count, and that has always pissed me off.
You can't find a 20 pin FPGA, right? You won't.
I'd be happy for a 44-pin quad flat pack with 1,000,000 gates. It was like back in. I can remember I needed like 1,000,000 gates back in the day or whatever, and I needed like 4 I/O pins. It was like serial in, serial out. That's all I needed, and the only chip that did the job was a 1,200-pin BGA.
Yeah.
I kid you not. So we had to use a 1,200-pin BGA for serial in, serial out.
And you're paying a ton for those pins. That's where all your cost is, right in there in those pins.
Exactly.
Yeah.
Yep. Exactly.
Yeah, I mean, in a way, when you look at the Zula board, it's kind of like that 40-pin device. It's not as small as a 44-pin PQFP, but it's kind of like giving you that simple 40-pin interface with a 1.5 million gate FPGA on it. And So it kind
Yeah.
of speaks to that need, but obviously it's still too big.
But that's not at the chip level,
yeah, it's
though.
not at the chip level.
Yeah.
I
At the chip
you know,
level, yeah.
you're
exactly.
familiar with Rent's rule, which says that the more gates you have, the more IOs you need, and they
Yes.
kind of follow that, and it makes sense, But there's always going to be us guys that would like to have a smaller package and could use a hell of a lot of gates to go with it. But those applications are, they're relatively few compared to the applications that need a lot of gates and a lot of pins.
Well, that's always been their excuse.
Yeah.
Yep. I've asked at some high levels, and they've always come back and said sorry, but there's just no call for that. And I'm going, well, I think you're wrong. If you build it, they will come.
Yeah. And they say, well, you go talk to Intel and get them to change their fab and their packaging, and then we'll put this together. That'll be Altera's responsibility.
Right.
What would solve that
like,
problem? What would get us around that problem? If we just had some kind of like chip printer that we could use in our home.
Don't start that. Don't go there, man.
Wait a minute.
You're not joining this conversation as a friend to me on that. I'm just you come to my house and you disrespect me.
I really got an issue I got to get out of the way here right now.
Okay, go for it. Come on, bring it.
All right,
on.
here it comes.
Go.
Chip printer, Arduino, women in engineering, 3D printing, open source. Bingo! I win.
Bingo!
I win. Everybody else put your cards away.
Dave, you know what? We're not. No more listeners on the show ever. No one who's ever heard of the show before is ever allowed on again.
What do I get for winning?
They know us too well.
What do I get for winning bingo? Like a date with Xenagome, or I promise I'll have her home on a school night.
You win a free course at Contextual Electronics.
Oh, there we go.
Party time.
We're sorry.
I don't think Selena's going to want to go there.
No, that's not the hot date spot these days.
Well. Okay, now that I blew everybody off track here.
You done?
Chip printer. Yeah, forget that.
Oh my God.
Actually,
so. Have I heard something about in recent news about one of the vendors? I can't remember who was thinking about addressing this market finally, the low pin count, high density market.
I thought, would it be Lattice?
Which doesn't exist at the moment.
Would it be Lattice? Maybe.
Yeah, it could be. It might be one of the minor players.
Lattice is always like the Uncola of the FPGA vendors.
Yeah.
Whatever whatever nobody else will do, they'll do it. Yeah.
Sorry, Lattice folks. I liked your video.
I mean, I do like Lattice. I haven't used the chips, but I do like what they do, and the kind of like avant-garde hippie-ish way they go at it. We're doing our own thing over here. You bastards can do it your way, but we're doing it this way. And
you can keep your 80% of the market share. We're going after 2%.
Yeah. What do you think about the? You do open source hardware for your development boards. You do open source development for your development boards, but do you ever see any prospect of the tools opening it up at all, or do you think it's just doomed to be, Altera, Xilinx, and Lattice and Microsemi trailing, that kind of thing?
Oh, they're doomed. They're too big. They're too big, too complex.
Yeah, there's so much intellectual property, and there's so much advantage to keeping that stuff secret for Altera and Xilinx that I don't see that they're ever going to open source that. I just,
no, it can't happen.
And if you do open source it, I don't see that it's any advantage to Altera and Xilinx. I just don't think that anybody's, the open source community is going to be out there, making any real improvements for them.
And you wouldn't want to. These things are complex enough and buggy enough, dare I say, at the best of times. To open source it would be absolutely foolish. Now, I've heard that the FPGA companies, they have more people dedicated to the software than they do to all of the hardware, testing, verification, everything.
I've got to believe that.
They are effectively software companies. Mm-hmm. That's effectively what they are.
Yeah,
the software is that big.
and they're probably getting at least a little bit of help from their foundry partners. I mean, the foundry partners are using the FPGAs now for the process drivers. Back in the late 80s and 90s, they were using memory chips for the process drivers. Now they use FPGAs. Because the
you mean like how they're leading edge? They're doing like the 14 nanometer stuff.
If we can get the FPGAs through there, then we can get anything through. Like they used to say, if we can get the SD, the DRAMs through here, then we can do everything else.
Right.
Yeah. Flash. Right. Yeah. Exactly.
Yeah. So they're using the FPGAs.
Yeah, it's true because the logic unit, or however they all have different names for them, but the logic unit with the SRAM cell and then the flip flop and everything else.
Yeah, I mean they're just.
That's the same usually, right?
Right, exactly. Yeah, it's just a big old regular array. It has a little heterogeneity in there. You got little blocks for the DSP elements and little blocks for the RAMs and stuff like that. But then the rest of it's all a great big sea of identical logic gates going through there.
Yeah, right. And they get process improvements, and then like the fabric improvements sometimes too, but mostly that's all process based, where they're getting better silicon. Yeah.
And then it instantly doubles your speed and halves your power. And, allows you to put twice the density. And,
And you have to use a 0.25 volt voltage rail and everything else like that. Like those every friggin' part these days.
What is the current lowest FPGA?
I know the ones that I've been using, around 1.1 or 1.2 core voltage, I believe.
Yeah.
I don't know.
Isn't someone down to 0.9 or something stupid?
There may be.
I heard 0.75 actually. I thought I remember
0.75, yeah, right.
Because I remember thinking like, wow, that's really close to a diode drop. It's like dangerously close. That's like no noise allowed. So you don't have to deal with that kind of stuff though on your boards. It's I see linear regulators on boards. That's a good indication.
Yeah, you got. The good thing about the Spartan 6 and the Spartan 3A is that they dropped out that 2.5 voltage, and all you have to do is have the 3.3 and the 1.2, and so you can bring in the 5 volts from the USB, put a couple of regulators on there, and you're ready to go. Versus having the 2.5, which is really just some to run the garbage JTAG stuff on there. For the most part, the configuration circuitry was doing the 2.5. I think it was all auxiliary stuff, so it was kind of a waste to have that out there. But so it makes the chip a lot, it makes the board a lot simpler to have it that way.
What about the I/O voltages these days? And they're continually dropping support for 5 volts. Next thing you know, they'll be dropping support for 3.3.
Well, hopefully not soon, because there's still a lot of stuff out there that needs to go with the 3.3. But on the very high end,
5's annoying.
Yeah, but on the very high end FPGAs, that are being hooked up to the very high end chips to make things go, then they may be able to get away with starting to drop out 3.3. But for the bread and butter systems, which are using the smaller FPGAs and trying to push those into more and more applications where there may be more and more volume, then they better at least stick with the 3.3.
Yeah,
but there's still a ton of interest out there with 5 volt stuff.
With 5 volt interfacing.
Well, especially because you can use them as replacements for other 5 volt chips that are dropping off the map too, right?
Right.
You can't get those anymore.
I built something called the Logic Pod, which you can put the Zula board into it, and it essentially brings all 33 I/O pins out to this header, and then you can either set the header pins to run at 1.8 or 2.5 or 3.3 or 5 volts, and a lot of people want that Logic Pod because they want to interface to 5 volt devices. So
Did you have external translators for that?
Yeah. The like the 16T 245 from TI. Those are the only ones I could find that would handle the 5 volt. There's an equivalent from NXP, but it's only going up to 3.3 volts. So again, dropping the voltages down.
So they're even dropping support on the bloody translators.
Exactly.
The world's going to shit, I'm telling you.
Eventually they're just going to put them out in a field, run over them with a big bulldozer or something,
Yeah. Go join my book.
So what about your customers for XESS? I mean, so who do you see using this stuff? Maybe to help our listeners kind of get an idea of how they might use it in their own projects.
Oh, well, tons and tons of students, tons of small guys in engineering firms that just want to get familiar with it, need a quick way to, get it into the circuitry. Take mine and you can hammer it into your circuit board and it's going to work. Whereas the other ones are all kind of like standalone boards that have headers that pop off of them, or they're more like they're more like standalone computers or standalone development boards.
Yeah, use like a ribbon cable and you'll you can be able to connect.
Yeah.
Right?
So I mean, you had your guest on last week, Dave from the the Fluke designer, and he was talking about with his new job at MSI or MIS, Measurement Institute.
Rice Lake.
Oh, okay.
Rice Lake, it's called.
And he said, they're doing those load cells that measure, weight of, he said there's no difference between a 5-pound load cell and the 5-ton load cell. It's all the same thing. So he designed that little 1-inch circuit board that has the amplifier and the other circuitry that's needed in every load cell.
And then you could just
drop it in,
plonk it anywhere you want.
That's the same.
Yep.
That's the same problem I had with my FPGA boards. Is people kept asking me for different peripherals that go around the FPGA. So they said, "Can you spin a new board?" And we'll buy we'll buy 5 of them, and we'll pay pay double the cost. And you can't do that. And you try to explain to them, and they're coming from a university background, and so they don't really understand that you can't spin just 5 boards and do all the development for that. So I got to the point where I said, I'll just put all the good stuff on one little board here, the FPGA and the SDRAM and the programming circuitry, et cetera, so forth, and then I'll put peripherals around that can be plugged and unplugged. And then whenever anybody wants anything, I can build a little board for them, and then it'll do that. And that kind of, was my attempt to try to get to like lean manufacturing that, one of your guests, Eric Ries, Reese talked about that. Now that, you don't have to build the whole board from scratch every time. You can build just the little module that does just the little thing that you want to do. You can do that a whole lot faster and get that out a whole lot quicker. And you don't have a lot of infrastructure involved in it anymore. So you can iterate it. You get it out to the customer and say that, and it does kind of what I wanted to do. But if you could change this or that, and then you can go ahead and do that. And that's a capability I didn't have before, because you had to build boards that were much bigger and more complicated. And when you change one part, other parts would change.
Right.
And then somebody wants something different. So that was kind of where I started from. A few years ago when I changed the kind of orientation of the product line around to being more of this component architecture versus the all-in-one architecture.
That's good. Do you run into speed issues at all? I mean. That's always one thing I think about with doing connectors and stuff like that, especially like the 0.1 inch kind of standard headers. But that doesn't really start to kick in until a couple hundred megahertz, right?
Well, it'll definitely kick in around 100 megahertz, or 50 megahertz. It kicks in, but mostly what you're seeing is the high speed stuff was between the SDRAM and the FPGA, because you're doing a lot of data swapping and things going on there. So that's all incorporated on the same board through very short traces. And then when you get off of the FPGA off the board, then you usually go into lower speed peripherals with the I2C interfaces, or simple bus interfaces, things like that that aren't going in the 100 megahertz region, so you can get away with a lot that way.
What do you usually clock on the FPGAs at these days? Is it still hovering 200 megahertz or so in terms of like internal clocking, not I/O?
Yeah, it's fed with a clock of 12 megahertz, and
it's all PLL,
and then it's all and that's it's kind of strange that people still kind of key off on it and say it's only got 12 megahertz going in, and people don't understand that there's a lot of there's a lot of capability in there to make as many clock speeds in there as you want. So, but internally, a lot of the example designs I put out are 100 megahertz designs, but they're pretty easy to route. They don't have a lot of timing problems, and the SD-RAM is 133 megahertz. So, if you go too much faster than that, you're definitely going to have a problem.
That's another thing I usually find with FPGAs too is like, you tell someone, oh, this is a 100 megahertz design, and if they're used to like micros or even like microcontrollers or microprocessors, right, where oh, well, my computer runs at 4 gigahertz. It's like, yeah, but I'm running 25 channels in parallel. Right. I'm doing the same amount of data overhead, and it's just like it's such a crazy comparison.
Right.
It's like you don't need that. In fact, you're burning more power.
And your PC's drawing 100 watts.
Exactly.
I mean, just a chip.
Because they're they're in the sequential mindset, and you're in the parallel low latency mindset.
Yep.
Completely different.
Although FPGA can match that. You can get ones that operate ridiculously high speeds, and you have to put massive water-cooled heat sinks on the bloody things to get the heat of them out, just like the latest Intel processor.
And a lot of your board areas eaten up with all the bypass caps that you got to put around them.
Yeah, that's right.
Oh yeah, and the 12-layer board to route out all the bloody I/O pins.
Yeah. I mean, on the Zula 2 board, I've got the 256 ball BGA on one side, and I've got the SD-RAM on the other side. So luckily, I was able to find a routing that would get the pins from one to the other through a 4-layer board. Using
nice
2 layers.
Yeah,
for
that's
power
not
and
easy,
ground.
folks.
Yeah, but I mean, when you talk about pin assignment, that's where it's hairy. Is on the printed wiring board. Is when you're looking, man, I got to get this pin over here, and I got that pin over there, and the FPGA...
Printed wiring board? Haven't anyone called it a printed wiring board since 1930?
1930,
I do that every now and then. I was talking to my sister on the phone a few months ago, and we were talking about something. I said, well, that motion picture came out a few days, and she said, motion.
Oh, I was listening to a phonograph last night.
Grandpa. But yeah.
And I was listening to this
I
latest song on the hit parade.
I talked to the haberdasher, and
But yeah, I mean, the ability to swap the FPGA pins around and everything, and get the pins that are needed close to where they need to be. I mean, that's pretty essential for getting the board layers down. But yeah, if you can't do that, a 12-layer board is definitely in the running for you.
That's painful.
Yeah.
So tell us about this. I think we talked about it on the show a while back. I don't know how many episodes ago. But what about this ebook or I don't even know if you call it just a PDF, I guess.
FPGA. FPGA is now what?
Yes, I always like the title. It's very incredulous.
Yeah.
Like, what the hell?
I've got an FPGA now. What do I do with it? And I've written a number of books. Both, I did the self-published book, and I've written for Prentice Hall, and just writing books is not a very good way to get paid. Forrest Mims notwithstanding, writing books is not a good way to make your money. But you can justify writing a book if you can sell something that goes with the book. In that case, it's the FPGA board. So even my first book, FPGA Workout, it was sold mainly with the idea of selling boards that go along with it. And so FPGA is now what is kind of like the latest incarnation of that. And I just go through design examples, building up all the way from, installing the software up to, compiling designs with software, simulating, getting them downloaded into the board. In this case, it would be the Zula or the Zula 2 board. And then how to use peripherals like the SD-RAM. And I've still got some chapters to write, but I'm thinking that kind of format for a book may be an outmoded way to do it now.
Well, maybe, but if you keep writing chapters in there that's writing tutorials sucks donkeys, then I will always read that. That's what immediately drew me to the book.
Maybe, Chris, maybe I could satisfy that just by, writing chapters, of various rants about, send in a topic and let Dave rant about it.
There you go.
That would keep you happy. But
that'll work fine. You do a weekly column.
But when I've got a ton of Python books here, but I found out when I want to write a Python program that what I do is I go out onto the Google and I type in what my question is, and I go and I find somebody to solve that. Yeah, the big old answer machine, and it comes back with the answer for me, and I learn a language that way.
Yeah.
And so I'm starting to think that maybe there is a better way in terms of writing a tutorial, so that it's almost like an executable tutorial broken down into little chunks that are easy to find, instead of this big PDF file that nobody ever seems to find.
Oh no, that's a good call. That's and having him like as modules where you can kind of jump in and out. That's nice too. Which is how a lot of books are set up. But
and I've been
you have to go get the book.
I've been looking around. There's a you may have heard of it. There's a language called MyHDL that.
I was going to ask you about that.
It's just a Python library that you can load up and do logic design with it. And I'm thinking that if you can do that, there's another thing called Python notebooks now that are. Dave, you may have been familiar with a program called MathCAD, but it used to allow you to write notebooks and insert figures and write out equations and everything. And Python notebooks are kind of like that, and you can execute the Python code right in the notebook, and the student can run it. He can modify the code and run it and see what happens. And if you could make a logic textbook that has, MyHDL code in it, and then allows the students to change the MyHDL code around to change the way the circuit works, and then view it in a logic analyzer that runs right in the notebook. Mm-hmm. And then I've got all this Python interfacing that goes to the Zula boards, so they could eventually get to the point where they're downloading the program into the FPGA that's on the board and running it and getting all this status information back from that. I'm thinking that would be probably a better environment to learn in, rather than just have the PDF book and trying to follow through it. Because I can't tell you the number of people that say, man, I had to go through 80 pages in this book to, get an LED to blink. And the reason is because it's 80 pages of screenshots that say, every step you got to go through. This is the screen you'll see. This is the next screen you'll see. You do this, click on this link, blah, 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 and you go through, and it is 80 pages, but it's because it's 80 pages of everything shown. Yeah. And
80 pages, 120 words, right?
Exactly. I mean, it's the easiest book in the world to write because it's just cutting and pasting stuff from the tool over into the book. But it has a bad marketing feel, in that people think they've got to go through 80 pages just to get from one end to the other. And I think that there's probably a simpler way to get people started with FPGAs than having them, all of a sudden throw this big tome down in front of them, bonk, and then they go, oh my God, here we go.
Oh, my fingers.
Yeah. I mean, that's...
Well, yeah, you're right. It's almost like you almost need like an Arduino module for FPGAs.
FPGAs. Well, I was in the process of designing a FPGA Arduino compatible board at one stage, but never got it finished, unfortunately.
I don't think even like compatible though, because there are others out there like that, and there's also plugins for BeagleBone and stuff like that. But I mean, just like the same kind of like Dave's talking about with getting that first blink is one of the powerful things about an Arduino, is getting to that point where you say I did that, and then you're hooked. Then you'll go read the 80-page manual.
Right. Yeah. I mean, exactly. those FPGA boards that are going to be sitting on top of BeagleBones and Raspberry Pis aren't really solving that problem, because now you've got how do I program the FPGA, and how do I make it talk to the Raspberry Pi?
I know.
All right, I'll spend 6 months going program on the Pi, and then
I mean, if you think you're solving a problem by doing that, what you're really doing is you're making two problems.
Right. Yeah. It's totally true.
All right.
It's true.
I mean, I gave a talk once about an FPGA board that I built for Altera that had 8 FPGAs on this ISA card, and you had to program the FPGAs to talk to each other through these predefined buses and everything, and there were no real tools to handle that, I just said you write the programs, and then you know the pin assignments, and go from there. And after I got done giving the talk, a guy from the audience came up to me and said, "You're scary. you're a scary, scary person. Do you think any of us are going to do that?" But I mean, it's a big cognitive load to manage all of that, all those pins that are going on there, and it's a big cognitive load when you get a processor and an FPGA together. All of a sudden, now you got a sequential machine and a machine that's definitely not sequential trying to talk to each other, and it's really not simple. I mean, that's why.
So is the
that's why I think that's why I think the Zinc is a good step forward, in that they're integrating the processors and the FPGA more tightly together, and they're putting an integrated tool set together there. And I think that's going to be easier than common two different boards together. Anyway, my opinion.
So has the Arduino of the FPGA world yet to happen? And is it inevitable, I guess? Or is it just too darn hard?
I don't believe it's too hard. I think that I'm sure it's not. I think that we've just got the wrong language. That's interesting. Well, I think something like MyHDL is a lot simpler, and you can build things on top of that do even more levels of abstraction. I mean, if you another implementation of the same ideas is MATLAB and what's the other company? National Instruments.
Oh, National Instruments.
LabVIEW. Well, there comes the argument, though, that you're not learning an industry tool. Okay, you might be able to get a job done, but then you're not really learning a tool that's used in industry.
Well, Arduino's not either.
So from that point of view,
I mean,
that's
yes,
true,
it is. Yes, it is. No, Arduino is real C. You are programming in real C.
It's not
real C. It is real C.
It's
dude.
not. It's not real C. Go look it up right now.
I
look it up right now. It's not. I know it's not. It's called wiring, and it's not. It's not real C. It's C.
It's real C.
Well, there are two environments for Arduino, aren't there? I mean, I thought that there was there is the non-C environment, which is what you're talking about, Chris.
The Arduino environment uses the GCC C compiler.
It's not real C.
It's real C.
Okay.
It's real C. It's just got a couple of top-level things taken care of, like the libraries and the configuration stuff. But apart from that, you're writing in real C.
Okay.
Sorry, dude, you are.
I've never programmed an Arduino, so
it's close enough to real C.
We don't need to argue about this. It's fine. Yeah, we're talking about FPGAs.
We don't, because I'm right.
No, you're not.
but see, that's the argument. Like with the LabVIEW and things like that. Yeah, you can get a job done really easily, but you're not using you're not learning. A proper industry tool. Or if you get, a nice basic interpreter or something, that's great for your microcontroller. That's wonderful. You can program it, but who the hell uses basic in industry?
If you're getting a job done, does anybody really care? I mean, isn't it a lot cheaper to buy the tool than it is to try to educate the people?
That's the argument. Well, that's the argument right there.
I mean,
it's. No, if you're getting a job done, there's nothing wrong with that. But then you'll have the whole bunch of people in the industry going, well, you're not learning a useful industry tool.
And my point would be that
you're not learning.
There's not an economic justification for me to learn the real industry tool because it's going to take me longer.
There may not be. That's
there may
right.
Not be.
And so I'm not pro or against either way. I'm just stating the argument. There's always going to be that big argument there, is when you get those real high-level abstraction tools, like we're talking about using Python to program, HDL, FPGAs.
But in the end,
in
the end, that does compile down into VHDL and Verilog.
Right. Yep.
But the point is, can you get a simplified environment that will get people introduced to FPGAs the way that the simplified Arduino introduces people to microcontrollers? And I think yes. I mean, those are
it's possible.
Yeah, those are existing tools that are expensive, but they will do that. They just haven't gotten to the point where they're widely available to Tom, Dick, and Harry that want to buy a little FPGA board and use it. But I think that free open source tools like MyHDL and Python may be a way to get you there.
That's interesting.
And there may not be an incentive for somebody to actually put the effort in to do it either, because FPGAs are that niche thing. Like, if you just want to flash a LED and do some other stuff, well, use an Arduino or some other micro board, there's just no point.
It's probably going to come from the open source community by a guy that's interested in doing it. There's not a great big market for people, because the people that are doing that need to be introduced to FPGAs is, it's not a big market. It's not until they're designing base stations and things like that people want to service them.
Right.
I mean, exactly. Arrow and Avnet couldn't give a shit.
Yeah, and you're not going to use your FPGA in your little wearable electronic LED flashy gadget. It's just
overkill and too much power.
There's just no point. That market's already solved. Yeah, exactly. It's already solved.
What do you see most people? I know about the regional differences, but what do you see most people programming in when they are programming directly? Is it mostly Verilog or VHDL, or what do you see?
Well, most of my people eventually get over to VHDL because I provide all my examples that way. But
nice.
It's you got the obvious bifurcation that everything to the west in California and I think Asia is Verilog, and everything to the east, east of the Mississippi all the way over to Europe is VHDL. But,
all the military stuff's VHDL, right?
Yeah, but it's such a tiresome argument. I'm just so sick of it. I mean, the tool, neither one's better than the other. They both do kind of the same thing. They both are a pain in the ass sometimes. For different reasons, and
totally agree.
But it's what you've got, and it's what you got to use. So go ahead and do what you can with it. I mean, I get so sick of the internet where people say, "Oh, you use X, that means you are Y," and usually X is Verilog and Y is dumb. They just jump from one thing to from one little piece of evidence to this massive conclusion. But like I said, these are the things that you got. These are what you got to use, and please don't make value judgments because I'm trying to get a job done.
You see that because then people don't have they don't have selection on the tutorials then.
Oh no. I mean, I'm not gonna. I just don't think it's worth the effort. I think that if you know one, you can learn the other. It's not a big semantic gap. The hard part, and I mean, Dave, you've talked about it before. The hard part is the parallel nature of it. I mean, if you get the model in your head about how circuitry works in parallel, and you understand that parallel model, then VHDL and Verilog are going to, do just fine for you. But if you don't understand that parallel model, you can't write either language.
Yeah, that's why I've always actually preferred, doing FPGAs and PLD stuff and programmable logic in schematic capture, because it's something that I'm always familiar with. Oh, I need a flip flop there. I need a counter. Drag it in. There it is. Hook it up.
In my opinion of schematic capture is I hope that I never have to do it again. But the problem I found was when Xilinx updates their tools, their schematic capture stuff does not go along with the ride.
I see those gates there, but I'm not doing anything with those. Nope, not going to touch it.
They're always abandoning you on schematic capture. The tool, the file formats change. They we can't do anything with them, and I've always had a problem that if you're an OCD kind of person, you spend all your time fiddling with the schematic, making all the wires go the right way and everything. And
you're right.
It's just
90-degree turns.
It's like being thrown into a tar pit. You're
right. But it's something familiar. I mean, every electronics designer knows about gates and flip flops. They understand it, right? But how do they to get your mind around how a counter works in HDL?
Yeah.
Code is an entirely different ball game. There's an interesting thing that when I was working at Altium, they found out that in the military side of things, right? They used schematic capture instead of HDL because if it was HDL, it was deemed to be source code. So source code came under a different set of rules, which meant that they had to verify each line of code in their product, right? And it'd cost like there's some generic cost of like $100 per line of code to verify code in the military world or something.
Couldn't they have passed their HDL through the thing that converts it into a schematic diagram that nobody in the world can read?
God. Talk about spaghetti.
That's what a lot of them did. So they'd put in schematic, and then they'd go, look, here's our schematic. This is not a programmed product. It's schematic, even though then they'd use the schematic to regenerate the HDL.
Tiny gates
and that's how they
inside.
avoided it.
You know what? If you showed me... If you showed me that schematic, Dave, at a review meeting or something, I would say to you, you scare me.
Yeah, I know.
Just punch him in the nose and walk out of the room, really.
Yeah. But anyway, that's what they did. That's what they did to get around, and a lot of other big companies to get around, especially in other regulated markets like medical and stuff like that. Source code comes under different rules. So if you do it in schematic and it generates the HDL, then that's fine.
So, I'll say that
anyway, I thought that was
two
cool.
things two of the things I really hate about schematics are, making a big change to your architecture is a big deal in a schematic, not as big a deal with HDL, and doing a diff, version control in a schematic is a lot harder than doing on a HDL. So I'm getting these messages here that say better finish it up. You guys there? Hello.
Nope. Hello.
Sorry.
Dave doesn't know how to type messages to just me, so
okay.
I'll take that out. Yes. What were we saying?
Yes, because we are at 100. We are at 100.
Yeah.
An hour and 21. Hour and 21 minutes.
Sorry, guys. I haven't talked to anybody in years, so running off of the mouth.
Brilliant.
So I wanted to ask, have you found limits on the MyHDL side of things? Because I am intrigued by this. I do think it's an interesting project. Have you found any limits on what it can do?
I haven't explored it in detail yet, but my concern is how well it's going to handle non-logic things in the FPGA. Like, how does it handle the JTAG interface that you can use in the FPGA and hook to your circuits? Can it handle that? Can it handle, how would it handle a microblades if it was in there? Does it have representations for these very high level blocks that you can drop in? Because, obviously designers make a lot of use of those because it's prepackaged, and it's supposed to work when you put it in there. And, you'd like to be able to do that in MyHDL. Are we going to have to clean room design those ourselves and put that into the MyHDL library in order to make that work? Now, there's probably somebody out there screaming right now, "Oh, you idiot! We already know how to do that." I'm not familiar enough yet with it to tell you that. But that would be a concern that I have.
Well, that's interesting with those, because I know the FPGA guy that I worked with is very vehement about that when he's like talking about being able to port designs and making sure you don't use like the native stuff from a vendor, so like the special blocks from Xilinx or Altera or whatever,
right?
Kind of abstracting that out and stuff. And that is another question about if MyHDL would do that kind of stuff, or then when it when Xilinx updates their software, if it's going to break all your programs there and it has to.
I mean, I hate those special purpose blocks. I know why people use them because they get better density, they get faster speeds, but whenever you move from one family to another, those macros change, and then you got to change the design around. It's so much. I love the fact that you can infer a lot of this circuitry from VHDL or Verilog, and it'll be put in there automatically for you. They'll drop the primitives in there for you, but I understand why people do it, but it is a pain to have those special purpose modules.
Well, that's actually a good reason to start. With, like Dave said, with the the schematic side of things, because a lot of the best designers I know with FPGAs, they understand. When they type a line of code, they say that's going to be a flip flop right there. That's going to be a register, whatever. And it's like if you don't do that and you just kind of blindly coding, like I do. It doesn't work out well, right? You're like, oh well, I typed 3 lines of code and my part's full now. What happened here?
Yeah.
You actually have to have that association so that you understand that while you're coding.
I mean, what you really need to do nowadays is drive the excuse me, going through puberty here. After 40 years, but you should drive the compiler around a little bit, try little pieces of code, and then bring it into the RTL viewer where it shows you the gates for it and get a feel for it. But after a while, you probably want to get away from that level, that kind of primitive level of coding, and get up higher in abstractions. As long as you understand what you're doing, and primarily you just have to understand that parallel mode of execution and how things work that way. But it's, like I said, when Verilog or VHDL can infer, RAMs and other things from loops that you put into the coding, that's pretty powerful, inferences going on there, and you'd like to make use of that and go up even higher. I've seen entire microcontrollers described in a couple of hundred lines of VHDL. Because they've got the abstractions right, they've got the macros right that they put into their code, and you can read through it and say, yeah, I see how that is a processor. And since code is read a lot more than it's written, that's pretty nice to have.
Definitely, that's really cool. So you have a GitHub account as well, right? So you're sharing all your projects there. Yeah. Maybe people could go check those out.
They're all linked in off the website, all through the manuals and everything else. And GitHub is probably the place where most of my projects go now. I have some projects on the website that are linked there directly, but really the interesting stuff is all going on GitHub.
Okay. How is the experience with FPGA stuff in GitHub? Because I've had problems in the past with like a lot of binary files. I know you can exclude stuff, but
I think I put the bit files out there sometimes, but not often. But mainly it's just a couple of files. It's an XESS file, which is a project file. It's VHDL files, and it's a UCF file, and which assigns the pins, the I/O to the pins. That's and then there's a README file, and I mean, really, when you look at it, it's like 20 or 30 kbytes of code.
That's not bad.
Not very much of anything in there. So it downloads fast, it compiles pretty fast. So go from there.
Cool. That's really cool.
So no binary stuff.
And all your boards are open source hardware?
All the recent boards are. There's still a few of the older boards that aren't, and never will be, because it's not worth.
Which package?
Like the XSA board, the XSA 3S1000, which had a Spartan 3 1000 on it. That was done back in 2004, and it's not being sold anymore. I just discontinued that one, and it'll never be open source because it's not worth it. But all the Zula stuff and the Stickit stuff is all open source.
Using which CAD package?
It's in Eagle right now, but I'm making the shift over to KiCad. Primarily because Chris and was it Adam Wolf had that pretty extensive talk about KiCad, and then the fact that.
And Mike Osman too. Mike Osman's doing the dice show on there.
Yeah, I didn't hear that one, but then there's CERN that's doing the that's getting involved in KiCad, and I just get the feeling. I used to use a paid for program called Xera as for graphics design, but now I use an open source program like Inkscape, which is at least as good, if not better than that, and doesn't cost any money, and it gets improved all the time. And I'm having a feeling that KiCad is on that cusp between being better than Eagle. Like Adam said, it's not going to make you 10 times more efficient to be in KiCad or Eagle over the other one, but at least I'll be sure that my open source stuff can be opened by everybody now if it's done in KiCad, and that's not true in Eagle anymore. Plus, I'm not upgrading to the version 6, so now we're having all kinds of problems with people wanting version 5 or version 6, and it's a mess.
Yeah.
Right.
So, I'd just as soon get away from Eagle now and try KiCad if I can just get all of my design flow into KiCad the way I want it to be.
Hotkeys, man.
Nice.
It's all about the hotkeys.
Yeah, I need to get what I need to get my my board coster software moved over. That you can just punch a button and it'll go in and say I want to build 100 of these boards. How much is it going to cost? And it goes out to DigiKey and Mouser and pulls all the prices in for you and says, well, it's going to cost this much if you do it here, that much if you do it here, and get a good quick estimate on that. So I want to get functionality like that I got with the ULPs with Eagle. I want to get that same stuff
That is nice.
over on KiCad, and I'm hoping that they're going to integrate the Python scripting with the KiCad, which will make everything really easy to do, and I can pull over all those ULPs I use and use them on KiCad. And I think that's going to happen. I don't know if it's happened yet. I'm still looking around trying to figure it out.
Yeah, I think the Python stuff's in the pipeline, so it's not quite there yet. But yeah, it's cool. And if you're a Python guy already, that's a good start.
Well, I'm starting to do a lot more Python than anything else now. It sure is a lot better for me than Perl, because when I write something in Perl, I write it, and then 3 days later I say, "Huh? What was that all about?"
Was I drunk?
Yeah, really? Was I drunk?
Yeah.
I mean, it's got.
I'm pretty sure the guy that wrote Perl said that about Perl as well. I think
he's got so much syntactic sugar in there that there's more than one way to do it. Well, there's about 1 billion ways to do it in Perl, and you can't figure out any of them.
Does that mean you're not a Tickle guy? You're not a Tickle guy with the FPGA?
I've seen Tickle, but had some experience with it, but I don't like it very much. I mean, I don't know why, but I just don't like it very much.
Well, it seems like all of the back end scripting stuff for the FPGA, like place and route stuff, that's all Tickle. It's all glued together with Tickle.
Yeah, I mean, I don't really see that at the level I'm at. Mainly working at it from the front end, trying to get a design done. I don't really screw around on the back end very much, but I've just seen the TCL, TK stuff with the Python main graphical interfaces done using that. I mean, the default, and then nobody really uses it, but that's just happens to be the default for it. But I just don't like it. But I wouldn't call anybody stupid if they did like it.
Well, speaking of calling people stupid, Dave was right, by the way. I did look it up on Wikipedia. Okay. So it was C. It's wiring is a library, so we can end the episode with me being wrong.
See, if you listen to the show, you will learn something.
Brilliant.
If you stay with it long enough.
181 episodes in, finally.
But you're still not going to cave on the chip printer.
No, probably not.
No, you're not even going to mention it.
I'm neutral.
Yep, I win.
Yeah, all right. We had another neutral. That's fine.
I am Switzerland.
Well, thank you very much for.
There you go.
Thank you very much for joining us, Dave.
Thank you very much, guys, for having me on.
Where can people catch you? Where can people follow you and stalk you?
They can catch me on Twitter at DEVBisme, and my website is www.xess.com. That's like X-ray Edward Samuel. And I don't have a Facebook, or if I do, I don't want anybody to go look at it.
Good.
And that's about it.
All right. Well, Dave, thanks for being on. We'll push everyone your way as soon as we get more FPGA questions. Okay. So,
Thank you very much, guys.
It's been good talking about it.
Awesome. Thanks, Dave. See ya.
Talk to you soon.
Bye. We used to say, there was a joke about Bell Labs. A woman goes on her honeymoon. She comes back, and her friends ask her, "Well, what was honeymoon like?" And she says, "Well, my husband's a Bell Labs engineer, so he spent the honeymoon night sitting on the edge of the bed, telling me how good it was going to be when I finally got it."